Now let us see the comparison of bending moments for a simply supported beam and a continuous beam. So for that we will take a simply supported beam first. For simply supported beam, when it is subjected to a single concentrated load of W, we know the bending moment diagram for such a beam is W L by 4 at the center, and it will be 0 at the supports. At the supports there will be 0 bending moment because of simple supports. And if the ends are fixed, and it is subjected to a single concentrated load W and the span length is L, the bending moment diagram becomes a triangle. So it is the magnitude is WL by 4 at the center of the beam, 0 at the supports due to the simple bending, and there will be a bending moment due to this fixed supports at the ends. So that bending moment will be drawn like this. So you can see that this is this triangular portion. In the first case, this bending moment is positive, whereas in the second case the bending moment is positive as well as negative. So positive at the center and it is negative at the supports. So at the supports, due to the fixed or due to the restraints, we will have negative bending moments. Now we will extend this for continuous beams. So before extending for continuous beams, we will see one more example with UDL. So when a simply supported beam is subjected to UDL of W per unit length, the bending moment diagram will be drawn as a curved parabola. It will be like this. So the maximum bending moment will be at center and it is equal to WL square by 8. And the bending moment at the supports will be equal to 0. Now when we are extending the bending moments for the fixed beam, when the supports are fixed and when the beam is subjected to an UDL of W per unit length, our bending moment diagram becomes a parabolic due to simple bending. It is WL square by 8, and we will have a fixed bending moments at the supports. So this is positive, and here we have this part is positive and this part is negative. So we will have negative bending moment at the supports and positive bending moment at the middle of the beam. So this concept we are going to extend for continuous beam. Now, when we are considering a continuous beam, suppose we have three spans with simple supports. Imagine we have three spans with simple supports. So we have concentrated load at first support, we have an UDL at the second span, and again a concentrated load at the third span. So our bending moment becomes like this. Our bending moment diagram will be drawn like this for simply supported beams. Now when it is extended with a continuous beam, so since it is three spans, we will have 4 supports, 1, 2, 3 and 4. So we have 4 supports. So in these 4 supports we will take the same conditions of loading, concentrated load, UDL and again a concentrated load. So how will we draw the bending moment diagram? It is the bending moment due to simple supports is like this, and due to fixed support, that is, see here the end supports are simple supports. If the end supports are simple supports, you will have 0 moment at the end support. But the intermediate supports, even though the intermediate supports are simple supports, it will have some negative bending moment, restrained effect because of this intermediate supports, so that you will have some moments at this part. So that moment will be a negative moment. So when you are drawing the bending moment diagram, you will have a positive bending moment and negative bending moment. You will have negative bending moment at the intermediate supports and positive bending moment at the other places. So in the intermediate supports, we can choose another color, so that we will choose the blue color. So here we will have negative bending moment. So this is negative, and this is positive, positive, positive and positive. Now suppose here it is, we will make it another color. Okay, suppose the end supports are fixed. In the second case, suppose the end supports are fixed, our bending moment diagram will be changed to, the fixed bending moment diagram will be changed like this. You will have some bending moment, negative bending moment at the support also, if these simple supports are replaced by fixed support. Now, so what do we infer from this? The reactions of individual beams can be obtained by equilibrium equations alone. That is, for these cases, see, for each individual beam, only two unknowns for the first beam, again two unknowns for the second beam, two unknowns for the third beam. So you can determine the reaction of individual beams by using the equilibrium equations alone. But what is the case for the continuous beam? There is number of unknowns are 1, 2, 3 and 4. Suppose if it is fixed, you will have 2 at the fixed support, 1 at the simple support, another 1 at the simple support and 2 at the fixed support. So totally you will have 6 reactions. Now the equilibriums, therefore you have only 2 equilibrium conditions, but we have 6 unknowns. So the equilibrium equations alone would not be sufficient to determine the end moments. Now the beam deflects in the respective span and does not depend on the influence of the adjacent spans. It depends on the individual spans. Okay, the bending moment depends on the individual spans. Whereas in the case of continuous beam, the equilibrium equation alone is not sufficient for determining the end moments. Also, the magnitude of the slope can be influenced by not only by the load on the spans, either side of it, but the entire loads on the span of the continuous beam. So the slopes, see here, if it is fixed, the slope will be equal to 0. But if it is simple support, the slope is not equal to 0, and in that case the slopes and deflections and bending moments are influenced by the entire spans, the entire loading systems. So this is the difference between, or the comparison between, the bending moments for a simple supported beam and for a continuous beam.